Okay, so I'm just going to a very important question which comes in the IB board. My prediction that this question is a must, right? This question will be there. There's a video in the YouTube channel, right? You can go through the details of this emission spectrum, right? Now, always remember that whenever you are exciting an atom, right? Isn't it? Atom. What happens? The energy levels are here, right? Like this. The energy levels are there. So if you see that this is the first energy level, this is the second energy level, the third energy level, fourth energy level, right? So the first energy level having a lower energy than the second has a lower energy than the third, and so on. Means as you go up, what happens? The energy increases, right? As told by the energy levels, first energy level, second energy level, fourth energy level, right? Now, if you're exciting an atom, right? If you're giving energy to an atom, right? What happens? The electrons will be taking that energy and moving to the higher energy level, right? Is it clear? Very, very easy. That if the first energy level having energy, suppose 25, if the fourth energy level is having energy of 65, right? So we know that if we supply a energy of the difference, 65 minus 25, it goes to the higher energy level, right? Means 45 energy if you supply, right? 65 minus 25, right? It will go into the higher energy level, right? It absorbs energy, right? Absorbs energy, right? Now, when the electron comes back, right? When the electron comes back, it releases the energy. This is very important. It releases energy. How much energy will it do actually release? 45 exactly, right? You know what? This energy which is released, right? We can predict that what will be the frequency. This will be coming as an electromagnetic radiation. What's the equation? E is equal to h nu, right? This thing, right? This. So whatever energy is released, right? That will be exactly equal to the difference of the energy level difference, right? Isn't it? And what happens? That can we can calculate and tell also predict that how much amount of the wave will be emitted, right? Which wave will be emitted, right? What's the frequency of the wave, right? Isn't it? So that's a very important thing that whenever what's the emission spectrum? Emission spectrum is the energy released when a electron comes back. When the electron goes from a low energy level to a high energy level, energy is absorbed, right? This thing we'll be learning in the transition metals, right? That when the transition metals, what happens? The d orbital splits up, right? Isn't it? The same question of that transition metal, right? That the energy is absorbed. Energy of a particular light is absorbed, and the complementary color is seen, right? We learned it in the transition metals, right? Here what happens? In the hydrogen, what happens? When the electron comes back, it will release energy. We can calculate 65 minus 25, 45, right? This 45 will be equal to h nu. What is h? H is Planck's constant. That is how much? 6.63 into 10 to the power minus 34, right? Isn't it? Fine. And nu we can calculate. We can calculate the nu. Exactly the frequency or the wavelength which is emitted, right? So what's the answer? That the emission spectrum is what? When the energy is emitted. When the energy is emitted, we have to think like that. Emission is emitted. That when the electron is coming back, the difference is emitted, right? Because 65 minus 25, right? So energy move, the electrons move to the higher energy level? No, that's not emission spectrum. That absorption spectrum, right? We call it, right? Electrons move to the higher energy level, we cancel. See, cancelling out. This is the trick you have to understand in the paper number 1. Cancellation. That trick you have to understand. See, we cancel out these two from left to right, right? Now come to these two options are left, right? Lower energy and lower energy, right? So obviously, these two are right. Now come to the next part. Level by what? Releasing energy or releasing photons, right? Isn't it? So that's the right question, right answer, right? So this chapter is very important. That the emission spectrum of hydrogen will be coming. Second will be that if we see that when we consider the similar question, right? The question will be coming what? That as we move from the left to right, what happens in the emission spectrum? The lines get closer at a higher energy, right? You have to remember this part, right? Isn't it? This bit. That the other part, that in the emission spectrum, what happens? That the lines will be getting closer like this, right? Isn't it? The 5 lines will be getting closer. So if you move from left to right, what happens? The energy increases, right? Isn't it? And the frequency increases, right? Emission spectrum we learned, right? And the gaps close by, right? So the gaps close at higher energy or higher frequency. This question will also come, this or this, right? So be very sure of this, right? So fine. So this paper, this will be definitely there, right? Thank you so much. Thank you so much. Thank you.